Okay, so the last question is all about gases. And this experiment. A student blows up 2 balloons to the same size. She puts one balloon into a freezer. After a while, the student compares the 2 balloons. The balloon that has been cooled is smaller. Use ideas about particles to explain why the cooled balloon is smaller. So we know that as the temperature decreases, the particles move slower. Okay, they have a smaller kinetic energy. Now, what that means, that if they're moving slower, the particles will collide. Particles collide with the surface less frequently. There are less collisions. Okay. Particles collide with the surface less frequently, on average. Now, what that means, and also because they're going slower, particles collide with the surface with less, because they're going slower, they're colliding with less force. With less force. Now, because they're less frequently, less often, and they're less force, this means the pressure is less. And if the pressure is less, then it means the balloon is going to shrink. The pressure inside gets smaller. The pressure outside pushes it in. So this is the pressure is less inside the balloon. Pressure outside pushes the balloon inwards. So the volume decreases. Okay, good. So the student is now trying to do an investigation between the link. The student decides to investigate the link between temperature and the size of the balloon. She writes a plan. You'll change the temperature of the balloon by putting it into a freezer. To get a range of temperatures, I will put the balloon into the freezer for different times. I will measure the temperature of the balloon using a thermometer. To measure the size of the balloon, I will take it out of the freezer and line it up next to a ruler. To make sure it's a fair test, I will repeat the experiment 3 times. I will plot a graph of size against temperature. There are several faults in the student's plan. Identify 3 of these faults and suggest an improvement to correct each one. Now, we know that the important thing about gases is not the size of the balloon at all, but the volume of the balloon. So I think that is the first fault that I notice. Okay, the size of the balloon is not precise. What we need must measure the volume of the balloon. So that's one thing, measuring the size of the balloon. That doesn't mean anything to measure the size of a balloon. You've got to measure the volume of a balloon. Okay, the next thing I notice is that she's trying to use a thermometer. Now, how could you can't just put a thermometer next to the balloon and it will give you the temperature. A thermometer will be difficult to use to measure the temperature. So it doesn't give you the temperature of the gas. It won't give you the temperature of the gas in the balloon. So how will you make that better? Well, I think you need maybe to use the temperature of the freezer, actually have different freezers with different temperatures, or even maybe do it with hot temperatures and put the balloon into a bath of water and measure the temperature of the water or something. Okay, that might be a better way to do it. Place the balloon in. Oh, in fact, we did a very similar experiment, didn't we? We had this thing with the gauge on it, and we put that under the water, didn't we? We looked at how the temperature changed the pressure with the pressure law. Place the balloon in a bath of water at a known temperature. Okay. And the third difficulty is, I think, that this isn't going to work very well either, is it? To get a range of different temperatures, I will put the balloon into a freezer for different times. The balloon will change temperature really quickly. This won't give you lots of different temperatures. So the third fault is that the balloon for different times in the freezer will not give a range of temperatures. And again, the best method, I think, is to use maybe lots of different water baths. Use different water baths with different temperature, or many freezers. At different temperatures. Okay, and that's the end of the paper. Well done.